Now 8th sum, show that f of g of h is equal to f of g of h. Here we are doing composition of 3 functions. It is very similar to how we did for composition of 2 functions. Now we will see the procedure. So first, left hand side, f of g of h. Okay, first we usually solve whatever is there inside the bracket, right? So I'll take f of g. So this we can write it as f of g of x. This is how we did, no, for the previous sums. Now what is your g function? 3x plus 1. Okay, now in f function, in place of x, you're going to substitute 3x plus 1. So I will have 3x plus 1 minus 1. Plus 1 minus 1 will get cancelled, and I will have 3 into x. Okay, now how should we do f of g of h? So we will have f of g into h of x. Okay, you always have the first value outside and the second value inside the bracket to avoid confusion. Now we can have f of g. What is your h function? X square, right? Now in f of g value, in place of x, you're going to substitute x square. Okay, your f of g value is 3x, right? So in place of this x, you're going to substitute x square. So we will have 3x square. So the value of f of g of h is equal to 3x square. Okay, now we are going to check whether the right hand side is also going to give you the same value. So take your RHS as f of g of h. Okay, first we need to solve what is inside the bracket. So I will take g of h. So I'll have g of h of x. Okay, so g of, what is your h function? X square. Now g of x square, which means in g function, in place of x, you're going to replace it with x square. Okay, so I will have 3x square plus 1. This is my g of h. Then what you have to do, you have to find f of g of h, which means I'll have f outside and I will have g of h of x inside, which is your g of h. Okay, so f into, what is your g of h value? 3x square plus 1, right? So in f function, in place of x, you're going to substitute 3x square plus 1. So 3x square plus 1, and already there is one minus 1. So plus 1 minus 1 will get cancelled, and therefore your f of g of h is equal to 3x square. And therefore we have proved that LHS is equal to RHS. Now the second subdivision, again we have to show the same thing. So first I will take the left hand side, f of g of h. Okay, first we will find what is inside the bracket, f of g. So I'll have f of g of x. Okay, so f of, what is your g function? 2x. Now f of 2x means in f function, in place of x, you're going to substitute 2x, right? So I'll have 2x square. So therefore we will have 4x square. Now f of g of h. So I'll have f of g into h of x. Okay, f of g, what is your h function? X plus 4. Now in f of g value, in place of x, you're going to substitute x plus 4. So 4 into x plus 4 the whole square. Okay, expand this. So you will have 4 into this, you have to expand in a plus b the whole square. So x square plus 4 square becomes 16, plus 2 into 4 into x. So you will have plus 8x. So when you multiply, you will have 4x square plus 16 into 4, you have 64 plus 32x. So this is your f of g of h value. Now we are going to check whether RHS is going to give the same value. Okay, so your right hand side, f of g of h. Okay, first we will find what is inside the bracket, g of h. So g of h of x. Okay, what is your h function? X plus 4. So in g function, in place of x, you're going to replace it with x plus 4. So 2 into x plus 4, you can write this as multiply. So I'll have 2x plus 8. Okay, now f of g of h is equal to f of g of h. Okay, so f of, what is your g of h value? 2x plus 8. Now in f function, in place of x, you're going to substitute 2x plus 8. So I will substitute 2x plus 8 the whole square. Now expand this in a plus b the whole square. 2x square becomes 4x square. 8 square becomes 64. 8 2s are 16. 16 2s are 32x. So this is your f of g of h. This shows that LHS is equal to RHS. Third subdivision, f of x is x minus 4, g of x is x square, and h of x value is given. Okay. Again we have to find the LHS f of g of h. Okay. First we will find what is inside the bracket. So I will find f of g. So this is equal to f of g of x. Okay. So f of, what is your g function? X square. Now in f function, in place of x, you are going to substitute x square. So I will have x square minus 4. Now f of g of h. Okay. So f of g into h of x. So f of g into, what is your h function? 3x minus 5. Now this is your f of g value, right? So in f of g, in place of x, you are going to substitute 3x minus 5. So I will have 3x minus 5 the whole square minus 4. Now we will check whether RHS is giving the same value. So your right hand side, f of g of h. First g of h. So g of h of x. So g of, what is your h function? 3x minus 5. Now in g function, in place of x, 3x minus 5. So 3x minus 5 the whole square. Okay. Now f of g of h is equal to f of g of h of x. So f of, what is your g of h function now? 3x minus 5 the whole square, right? Now in f function, in place of x, you're going to substitute this. So 3x minus 5 the whole square minus 4. So we have proved that LHS is equal to RHS. Now the ninth question, let f equal to minus 1 comma 3, 0 comma minus 1, 2 comma minus 9 be a linear function from z into z. You have to find f of x. Now how do we find linear function? Linear function means the highest degree is 1. And the general equation of a linear function is f of x is equal to ax plus b. Okay, so this is the general equation of a linear function. Now the function is already given to us, okay, minus 1 comma 3, which means when the value is minus 1, the image is 3. When the value is 0, the image is minus 1. When we give 2, the image is minus 9. Okay, so using this, we are going to find out the value of a and b, and then we will finally substitute in this equation to find out what is the f of x equation. Okay, so what we are going to do here, first substitute minus 1 from this in place of x. Okay, so f of minus 1 is equal to, when I substitute minus 1, my image is going to be 3, right? So in place of f of minus 1, I will substitute 3. In place of x, we will substitute minus 1. So a into minus 1 plus b. So your right hand side will be minus a plus b. This is your first equation. We will mark this as some star. Okay. Now what we are going to do, substitute the next value. What is your next value? Your x value is equal to 0, right? So substitute x equal to 0 in star. So I will have f of 0 equal to a into 0 plus b. Okay, when you substitute 0, your image is minus 1. So I'll have minus 1 equal to a into 0 becomes 0 plus b, which implies b is equal to minus 1, right? Now substitute b minus 1 in the first equation, minus 1 in the first equation to get the value of a. So 3 equal to minus a minus 1. So 3, take minus 1 to the left hand side, it becomes plus 1 equal to minus a. So we will have 4 equal to minus a, which implies a is equal to minus 4. Now I got the value of a and b. I can substitute a and b in star equation. Okay, so in this equation, so f of x is equal to, in place of a I have minus 4 into x, in place of b I have minus 1. So this is the linear equation for this problem. Now the 10th problem, in an electrical circuit theory, a circuit C of t is called as a linear circuit if it satisfies the superposition principle, C of AT1 plus BT2 is ACT1 plus BCT2. A and B are constants, and we are going to show that this C of t is equal to 3t is linear. Okay, so when this condition is being satisfied, then C of t is called as the linear circuit. So to start this, what we are going to do here is, I will take C of T1 is equal to 3T1 and C of T2 is equal to 3T2. We are going to show that C of T is equal to 3T is linear. So this is just my assumption. C of T1 is 3T1 and C of T2 is 3T2. Okay. Now take the LHS from the superposition principle. What is the LHS there? C of AT1 plus BT2. Okay, now with this what we are going to do is apply the conditions that we have used here. Okay, see, C of T1 was equal to 3 into T1. So in place of T1 I have AT1 plus BT2, right? So I am going to substitute this on the right hand side. So I will have 3 into AT1 plus BT2. Hope this is clear. CT1 is 3T1, right? You have T1 and T1 on LHS and RHS. Similarly, in place of T1, I have AT1 plus BT2. So what I have to do with the right hand side? Again, in place of T1, I am substituting AT1 plus BT2. Okay, now after this, we are going to multiply inside. So first I will have 3 into AT1 plus 3 into BT2. Okay, then what I am going to do, take the constant alone separately. So I will have A into 3T1, again here B into 3T2. Okay, now by our assumption we can replace this 3T1 as A into CT1 and 3T2 as B into CT2. Okay, by this we are satisfying the superposition principle, and therefore we conclude that C of t is linear. With this we conclude this exercise. For further queries and doubts, please comment below.